Boa tarde a todos e todas, sejam bem-vindos e bem-vindas a mais um webinar do Education USA. Meu nome é Davi Medeiros, eu sou Education USA Advisor aqui em São Paulo, na Universidade Presbiteriana Mackenzie. No backstage estou com o meu colega, também advisor em São Paulo, o Murilo Artesi, que fica no escritório da FAAP. Hoje nós estamos muito felizes de poder contar com uma palestra, um webinar com uma universidade americana, né, a Syracuse University, que vem através da School of Information Studies, né, representado aqui pelo Mike Fandrich e a Susan Corriere, is that right? E eu vou só falar um pouquinho a respeito do Education USA antes da gente começar. Como estamos numa gravação, eu peço que as interações de vocês sejam então pelo chat ou no final, quando abrimos para perguntas, vocês podem abrir o microfone também, mas se não quiserem aparecer na gravação, por favor, não abram as câmeras ao final dela, tá? O Education USA é uma rede de escritórios ligada ao Departamento de Estado dos Estados Unidos. São mais de 400 escritórios no mundo inteiro e aqui no Brasil são mais de 40. A gente é realmente a fonte oficial de informações para vocês sobre aplicação para estudos nos Estados Unidos. E é por isso que hoje nós temos uma universidade americana aqui conosco, né? Então, hoje nós vamos falar, né, sobre a aplicação para information studies, né? Então, studying data science and analytics in the US, which is the right program for me? Então, essa é a pergunta que o Mike e a Susan vão nos ajudar a esclarecer, esperando então e desejando a vocês uma excelente oportunidade. Thank you, Mike. Thank you, Susan, for being here. So the floor is yours.
Great, thank you very much. Thank you for having us, and thank you for giving us this opportunity to speak with you all today. So thank you, thanks for joining us. My name is Mike Fandrich. I am a recruiting specialist. I'm on the enrollment management team at the iSchool, the School of Information Studies at Syracuse University. And I'm also joined by our Assistant Dean for Enrollment Management, Sue Carreri. Sue and I will talk today. I'll give a presentation on the field of data science and data analytics, and try to give you all kind of a comparison of some of the typical programs that exist within this field, the field of data science. So in terms of an agenda for today, we're going to give a brief overview of the field of data science in general, give you some kind of the highlights, some of the topics to think about. We'll give a comparison of some of the standard or typical types of programs that exist within this field. So that includes business analytics, applied statistics, data science programs that exist within computer science schools, as well as a kind of a special brand of data science that we know well at Syracuse University called applied data science. And then lastly, we'll finish up by trying to give you some tips for thinking about which programs might be the best fit for you. And then we'll give a brief, just very brief overview of our university and our school before leaving as much time as we have at the end for questions and answers. I will say before we begin, there's a lot of different sort of terminology, a lot of different terms that we're going to use related to data science, and some of it can be a little bit confusing, we admit that. So please definitely ask questions if you're not sure what we're referring to and we're using a particular term. We'll be happy to try to explain a little bit more about what we are referring to. So I will jump right in and give a brief overview of the field of data science. So the first term, like I just mentioned, that may be a little bit confusing is actually data science itself. So data science is one of those kinds of terms where if you ask 10 people what their definition is, you'll probably get 10 different answers. But we at Syracuse University, we like to think of data science as the process that turns data into useful, actionable insight. And what we mean by that is kind of represented here on the slide by this pyramid. And it's the process where you can turn data, which is a kind of a piece of information, whether that be a temperature, someone's size or weight, or maybe a price, which on its own, that piece of information, that piece of data doesn't actually mean anything. It doesn't have any context. It doesn't have any meaning. But you can give it meaning by giving it context. You can give that information more meaning, turn it into knowledge. And then if you can turn that knowledge with some insights into wisdom. And once you've turned the data up the pyramid, you're able to turn it into useful, actionable insight. And that's what we mean by data science, taking a piece of information, a piece of data that by itself has no meaning or no use, and you turn it into something that's actionable and usable in the organization that you're in. The second big topic I'd like to mention is that the field of data science is multidisciplinary. This is actually kind of the main idea that we're trying to get across in our presentation today. So if you take only one thing away, this slide is probably a good one. And what we want to convey here is that the field of data science is made up of components of many other different academic and professional fields. So if you take a little bit from math and statistics, you take a little bit from computer science and information technologies, and then you pair that together with business or other domain or field-specific knowledge, you kind of mix that all together, you have data science. And we'll mention this further into the presentation, but each of the different types of academic programs that we're going to reference lives within this Venn diagram somewhere. And the main difference between all the programs that we'll highlight is that they have different, they put a different emphasis on. So for example, some of the programs that we'll talk about have a great emphasis on math and statistics, whereas other programs focus maybe a little bit more on the computer science or information technology aspect. But they all are within the umbrella or kind of the broad spectrum of data science. And again, they differ in that they have different emphases on which they really focus their time on. So the third big highlight I'd like to make is that data skills are in demand. That's probably one of the reasons why you're attending this presentation. Their careers in data science and data analytics are really kind of exploding all across the US certainly, and also all around the world. And really in every kind of sector or industry that you can think of, whether it be healthcare or business, finance, government, not-for-profits, all of these different sectors have needs related to data and information. So data is becoming very, very prevalent. It's all over the place. And the increasing prevalence of data results in an increased need for individuals who understand how to use data, how to collect it, how to analyze it, how to turn it into something that's meaningful. So on the slide here, you can see I've put a screen grab from Glassdoor.com highlighting the 50 best jobs in the United States. And the field of data science is well represented on this list. As you can see, the number 2 job in the US is data scientist. And what that means is that when they say it's one of the best jobs in the United States is that it has a lot of job openings. So on the Glassdoor platform, there's a lot of job titles openings for data scientists. The individuals who hold these titles often command a great average salary. So as you can see here on the slide, some of these salaries are quite sizable. But also, and I think really importantly, all of these jobs have high satisfaction ratings. So individuals who hold these jobs rate their kind of satisfaction with their employment quite highly. So when you put all those things together, the field of data science is a great career for people to enter. But what do we kind of mean when we say that data skills are in demand? What actual skills are needed? That really is dependent on the job and kind of the situation that you're applying into. But we've sort of identified 5 different categories of skills that we think all data scientists should probably have. The first is that a data scientist should be able to collect and manage data. You should be able to analyze data, kind of crunch the numbers, derive some sort of meaning or insight from a data set. But then you also need to be able to apply critical thinking to that data set. So you need to be able to not just sort of do the technical aspect and really crunch the numbers, but you need to give meaning to the data using critical thinking, and also business and domain knowledge. So for example, if you're working in data science in the healthcare industry, if you don't know anything about healthcare, it's going to be very hard for you to put context and meaning to the data that you're analyzing. And then lastly, the fifth skill that I'd like to mention, and I think this one gets overlooked a little bit, but it's very important, is presentation and communication skills. So data scientists need to not only be able to do the technical bit, to analyze the data, collect it, analyze it, and do all the programming or coding or anything like that. You also need to be able to present your ideas and present and communicate the analysis that you've done. Otherwise, you've kind of just wasted your time. If the whole idea is that you're going to take your analysis and turn it into useful or actionable insights, you're going to need to be able to present and communicate what you found. So those 5 skills are really what many data science related programs in the United States try to teach students. So we've mentioned that data skills are in demand. So how do you go about getting those data skills? There are many, many, many different graduate programs, also undergraduate and graduate programs in the field of data science in the United States. So up here on the slide here is only a very small fraction of the universities and the academic program names related to data science that are available to students in the US. So if you are interested in studying data science, and you're interested in a particular university, or maybe you're interested in living in a state or region in the United States, I really encourage you to do your research online and also interact with university representatives to try to find out if they have a data science related master's or undergraduate program that may be a good fit for you. And keep in mind here that a lot of these terms are not well defined. So what one university calls a data science program, another university might call it their master's in data analytics, or similar, a business analytics program. Another university may call it their business intelligence program. So make sure you just ask questions and understand that some of these terms are a little bit interchangeable. So you need to make sure you do your research and ask your questions to find the right program for you. So just to make sure we're all on the same page here, I'll just give a couple brief examples of what we mean by data science. And I've picked 5 examples here that I think most people sort of understand and maybe interact with on a daily basis. A lot of data science has to do in some way with making predictions. So an easy example of that is in the finance industry. If you think about financial forecasting, stock market forecasting, individuals will try to use a data science model to predict what's going to happen in a market and then make an investment accordingly. Similarly, we also have classification algorithms in data science. The easiest example of that is your email spam filter. So your email platform that you're using, whether it's Gmail or Yahoo or Outlook, it will be looking at the emails that are coming into your inbox. Excuse me. It'll try to determine using a classification algorithm whether or not it's a legitimate email or a spam, and it'll route that into your inbox or into your spam box or junk box based on the classification that it comes up with. Another algorithm we have are clustering algorithms, so that's often used in market segmentation for advertising. It takes different aspects of you and the different information or data points that it may have on you, and it will cluster you into a group and serve you different advertisements based on how you've been segmented in the market. We also have association rules mining algorithms. You probably interact with these if you use Netflix or Amazon or Spotify. And what this does is it looks at your past history of things that you've liked or downloaded or listened to, and it gives you recommendations based on what you've done in the past. That's ARM, that's an association rules mining algorithm. And then lastly, it's kind of a big umbrella idea. We probably read about in the paper quite a bit about self-driving cars. That's a sort of futuristic example of machine learning and artificial intelligence, another topic that we like to study in the field of data science. So while we're quote unquote doing data science, what actually are we using? What tools are we using to do that? Oftentimes when you're working in data science, you're programming or you're coding in some way. And oftentimes you're using languages like R or Python to do that. You're also oftentimes managing data in different ways. So in what we call relational databases, you're often using SQL. But there's also non-relational databases, a little bit more complicated, using things like MongoDB. And also there are different tools to use in big data. machine learning and natural language processing. And then a really interesting and very popular thing to study now are dashboards and interactive visualizations, where you can use platforms like Tableau, Power BI, and the like. So those are just some of the tools we use in data science. So now I'm going to pass off to our Associate Dean for Enrollment Management, Sue Carreri, and she's going to sort of kick us off on a comparison of some of the different programs that are within the data science field.
Thanks, Mike. Hi, everybody. It's really a pleasure to be speaking with you today, and thank you so much for attending. Mike had talked about different data science types of programs, the business analytics, the applied statistics, and the data science that's done for computer science. I want to talk a little bit more about that. So if you're really looking to differentiate the different programs, I always encourage you to look at the curriculum and to see what the courses are. Okay, so in the US, we call it programs and courses. So courses make up a program, all right? So these are all programs, but they have different courses. One of the other things that can be very telling about a particular program is the school or college in which it sits, or the department which it sits. So I would also encourage you to look at that, because if you're taking a business analytics course, the motivation is usually to improve the business, the return on investment, finance data, maybe it's warehouse data to be able to move logistics and things like that. So, but the motivation is to usually make money or to improve the processes per se. In an applied statistics program, that sits within a math department, all right? And they are academic in nature. And let me phrase the fact that I am generalizing for the sake of trying to teach you a little bit about how to differentiate programs. You're going to see programs that are a little bit of both along the way. In fact, we're going to give you an example of ours, which is perhaps pieces of these. But applied statistics is usually in the math department. So there's going to be a lot of different mathematics, calculus, statistics, things like that. And then the data science that comes out of a computer science program is generally going to have the goal of improving technology. Okay, so they're going to create new algorithms to enhance technology, build new applications and things to make things better. Okay, next slide. So to differentiate a little bit more, a business analytics program is going to work primarily with what we call structured data. So that's numbers. So it's really easy to, if you have to put numbers in a table or organize something, it's very easy to do that, okay? Because numbers in themselves are organized and have structure and hierarchy. Applied statistics is the same way. But when you get into data science, you're dealing with both structured and unstructured data, okay? And that can get pretty messy. So the recommender systems that Mike talked about, those are unstructured data. So sometimes a recommender system might use a thumbs up, okay? So that's actually an image, but it has meaning. Another recommender system might use free text to tell you how a product is. So that becomes much more complex as to how we create the architecture systems in order to analyze that data. I think I pass it right back to you, Mike.
So just as these programs are using different types of information and different data within their courses, they also use different tools. So for example, in business analytics programs, you're oftentimes learning how to use business intelligence platforms like Tableau or Power BI. You often learn to use spreadsheet applications like Excel. I know many people probably use Excel on a daily basis, but in these business analytics programs, you often learn to use them as really in an advanced way. And oftentimes you also learn to code and program as well. In applied statistics programs, they have their own special tools with these statistical software like Minitab, MATLAB, SPSS, Stata if you're working in the social science statistics. And they also use, again, as its name implies, advanced statistical and econometrics techniques within their programs and within their courses. And then, as Sue mentioned, in data science, we're working more in kind of coding and programming, whether that's in R or Python or Java. Database management, there's all sorts of tools for that, as well as there's dozens or hundreds probably even of tools in AI, machine learning, natural language processing, and computer vision. So to reiterate a little bit of what Sue said, these are kind of the unique selling points that we see for each of these types of programs. So in business analytics, we're really looking at how you can use data, how you can align data and different information that you have available to you, and how do you put that into action to solve business problems? How do you use data to make decisions? Whereas in applied statistics, kind of the main selling point is that you're really gaining an advanced understanding of statistical models, statistical theories, and how they can be applied in different ways. So whether that's advanced regression analyses, time series, stochastic models, and another really unique part of the applied statistics programs is you often learn about different methodologies surrounding experiments and surveys and other forms of data collection. That's something that's covered maybe a little bit in business analytics and in data science, but definitely at a much higher level in the applied statistics programs. And then again, as Sue mentioned, in data science, we're really focusing on developing new algorithms, developing technologies, focusing on the data architecture and engineering of database management. And again, as I keep mentioning, machine learning and artificial intelligence. So again, we are generalizing. We're kind of boiling down very complex ideas into 3 or 4 bullets on a slide. But these are sort of the big picture ideas about what some of these programs really focus on in a general sense. And then lastly, these are some of the sample job titles or examples of jobs that students who graduate from these programs may take. So business analytics graduates will often become business intelligence specialists, applied statistics grads, researchers, and then data scientists can be, data scientists, data engineers, or data architects. And this is in no way to say that a data scientist graduate can't be a business analyst or an applied statistics graduate can't be a data scientist. We're again just trying to give you a general idea of some of the sample or example job titles that graduates of these programs could take. Now I'll kick it back to Sue to give an overview of a special brand of data science called applied data science.
Thanks, Mike. Okay, so as we were introduced earlier, Mike and I are from Syracuse University from the School of Information Studies. So we term ourselves an I school or an information school. You actually have one probably right in your region. Sao Paulo University of Sao Paulo is a I school as well. So there's about 100 what we call I schools across the globe. And the common thing with information schools is the mission. The mission is always user-based, okay? So we address information needs by serving the user, not by improving technology, although that is sometimes the means to serve the user. It is not the goal, okay? So we look at individual users or organizations or even whole countries as users, establish their information needs and meet those needs. So the field in an iSchool covers all different types of information. So when we went to develop our data science program, we wanted to deal with all aspects of information problems, the whole life cycle of information, of data. And so we started with acquisition, which is the collection of the information, all right? So we have to access the information and collect it first. And then we go to architecture. That is critical because if you don't organize your information appropriately, then you're not going to be able to analyze it later. Okay. So you have to, if you think of just two-dimensional architecture, think of an Excel sheet like Mike had mentioned. You know, what is going to be on the columns, what is going to be on the rows, and how are we going to represent the data so that we can later make our graphs and things that are meaningful and influence decisions. All right. So architecture is critical, and it can be extremely complex. But when I have a degree from the information school, and I'll never forget when the example that a faculty member brought in one day is she brought in all of these, and you're all too young to have ever done this, but hopefully you can imagine it. She brought all of these wallpaper books to class. And in a wallpaper book, you actually open the book and you look at each pattern separately to pick out the wallpaper of what you want. So they're themed a little bit, like there's a flowery book or there's a, you know, kids' room book or something, but you really need to look at it. So she was teaching us data architecture, and she's like, you take the entities of the different things and you categorize them based on those entities. So all of a sudden, one given pattern of wallpaper is going to have some attributes to it. So is it going to be striped? Is it going to be blue? Is it going to have a large pattern, a small pattern? And then you put them in a table. And then all of a sudden you can look at this table and you could say, well, I'm looking to do my child's room. They like cars and blue is their favorite color. And all of a sudden now you don't need to look at 10 books of wallpaper. You might only need to look at 5 different sheets. Okay, so that's like a little lesson in how data architecture is really important. And if you do that well, then the analysis is much easier. If you don't do that well, you do a lot of cleaning and a lot of editing to make the data clean in order to analyze it. The next phase is action. Okay, so now that I have that analysis done, I have my charts, I'm presenting them to the boardroom, how does that influence action? And that is the critical thing. And that is the reason that data science is such a fabulous opportunity these days, because it influences action. Whether that action might be investing in a new stock or making sure we have vaccines in a particular region. All of those data points are analyzed and then influence decision-making, right? The last phase we talk about is archiving, because we do not know today how we might repurpose information tomorrow. So it's important, just like the architecture is correct, it's important that that information be stored so that it can be repurposed in the future. So these are all things that an information school rely on, because they've studied information science and they understand classification theory and all of these things. So when we developed our data science program, we did so. Most data science programs are really focused on architecture and analysis, influencing action, but the acquisition and archiving are not part of them, but it is part of our program. Next one. Okay. So applied data science is has many different things that it contains. So there's a nice listing of the different focus areas, as well as some buzzwords, which Mike has already talked about. And you can see, you might say, oh, machine learning. Well, that's the same thing as computer science machine learning. And you're absolutely right. There's a lot of crossover between these things. But these are the different types of things that you will study. The first, the focus areas are actually the concentrations within our applied data science program, where you can take a really deep dive and understand like language analytics or data pipelines and platforms. That's kind of like how the information travels and where it sits, which is really critical for security and all of that, and making sure that information is available in real time so decisions can be supported. Next slide. Okay, so these are masters in applied data science, and we also have a similar program called applied data analytics at the undergraduate level. They're very similar. We use a different title for them just because they're more understood by the different markets in that manner. But I want you to look at all of these things that make up applied data science. And individually, they are all part of the other three types of programs: the business analytics, the applied statistics, and the data science and the computer science program. The difference is how they're aggregated in applied data science, because it's a convergence of both the technical and the managerial end of the field of data science. So I want to explicitly point out the range of domain. And what we mean by that is that you can work in any field. So with our applied data science program, we are teaching people how to manage data. It doesn't matter if it's medical data, if it's product data about, food or something, if it's environmental data about pollution. The skills to manage that data are the same. And then you can go out and apply those skills to your field of interest. That's one of the reasons that we don't have a requirement that students already know technology prior to coming, because what we'd like to do is we like to attract people with different domain knowledge. So there might be somebody that's interested in agriculture or something, or maybe interested in space, and they come and they learn how to use their data sets appropriately. Okay. Many different programs have visualization and predictive models. I would say both the computer science and the applied data science programs are strongest in that, because that usually does require some coding and such. And again, I think I covered the full life cycle of the data pretty well there. Next. I think this goes back to you now, Mike.
Yep, I will take back over. So the last kind of section of our presentation is I'm going to outline just some questions to kind of ask yourself to try to help push you towards finding the right program, kind of the right fit for you. So the first question to ask yourself is, how technical do I really want to be? So what we mean by that is, how deep do I want to get into the statistics, into code and Python, for example? Or is my real interest is, do I really want to be focused on organizational management, project management, and gain skills like that? Here's a quick kind of just graph to sort of show you at least how we envision how the mix of kind of technical and managerial skills break down based on all the different types of programs that we've outlined during the presentation today. So computer science programs are oftentimes very, very technical, and business analytics programs are often really incorporate a lot of the management kind of organizational skills as well. As we've mentioned previously, and I'll mention it once again, there are certainly going to be programs that sort of fit, are kind of a mix of these things. So there are certainly computer science programs that will have a management aspect, as well as business analytics programs that are very, very technical. But we show you this slide again just to give you a kind of an idea that in general how these programs kind of break down in terms of how mixed they are of technical and managerial skills. The second question I'd like you to ask yourself is, what domain do I really want to work in? Do I want to work in healthcare, in government, in finance, and which program that I'm interested in, which one really sets me up to work in that domain? Related to that, do I already have the domain knowledge? Do I already have a background in finance if that's what I'm interested in? Or should I be looking for a program to go study in that also is going to give me some of that domain knowledge? That could definitely impact your decision as to where to study. And then lastly, which point of the data life cycle that we've talked about, where do I want to spend most of my time? What am I most interested in? So are you most interested in collecting data, whether doing experiments or surveys or otherwise, collecting and organizing data? Are you more interested in the architecture, the infrastructure of data and how it's managed and cleaned up? Or do you like crunching the numbers? Do you want to focus on the analysis? Or would you prefer to be sort of at the tip of the spear and using the data for data-driven decision-making in a management perspective? So those are all kind of basic questions, but I think they can be useful to ask yourself as you begin to explore different opportunities to study in the field of data science. And when you do find a program that you may be interested in, we definitely encourage you to, number one, look at their website, but even more importantly, reach out and ask to speak to a university representative, because you can get a lot of insights from speaking with someone that you're not going to find just on a website. So if you do speak to someone, I think you should ask something like, what are the requirements for admissions into your program? For example, if you're looking at a technical field, do you need to have any prior background in statistics, or do you need to know how to program or code in order to join the program? If you're going for a graduate program, do you have to have any professional experience? Some programs require you to have a few years of professional experience, and others don't. You can also ask a university representative where their graduates go on to work. So for example, if you're interested in working in finance and you find a school that has a great pipeline into the field of finance, maybe that's a better fit for you than another school that maybe you were interested in previously, but doesn't really have that relationship into the finance field. Are there opportunities for experiential learning? So a lot of these professionally oriented programs like data science, you don't get as much, or you need more than just a classroom in order to really learn these fields. You need to be able to go out and apply what you're learning and get some hands-on experience. So we definitely recommend you ask a university representative what the opportunities are for internships or for doing research or things like that. If you have a particular topic of interest that you want to explore, we definitely recommend that you be very kind of upfront and ask specifically whether the program that you're interested in has that topic. And please keep in mind here, as I mentioned at the beginning of the presentation, that a lot of these terms are a little bit fuzzy and there's not always great definitions, or not everyone uses the terms in the same way. So for example, what we may call applied machine learning at Syracuse University, another school might call advanced data analytics. And if you don't ask the question about, oh, do you have machine learning or do you have advanced data analytics, you may kind of just skip over that program because you're not all the terms aren't interchangeable. And then lastly, I highly recommend that you ask, when you find a program that you're interested in, you ask to speak with a current student or an alumni from that program. As much as people like Sue and I like to speak with prospective students and answer your questions, you can oftentimes get another perspective by speaking with a current student or someone who graduated from that program. They can give you kind of the student's perspective and really show you what it's like to study at that program. And then the very last thing I'd like to point out is there are plenty of opportunities to try out kind of data science for yourself. So if you're brand new to this and you think it might be interesting, but you don't even know where to begin, there's plenty of opportunities for kind of free webinars or modules or different opportunities just to try out things like machine learning or statistics or writing code in Python. And I've highlighted some of those opportunities here on this slide. Again, most of these are free. There are probably also paid elements, so make sure you know what you're signing up for. But there are many opportunities to try things out for free just to see if it's something that you're interested in doing. And now to close us out, I'm going to hand it back over to Sue just to give a brief overview of the iSchool at Syracuse University.
Thanks so much, Mike. Right in front of you is a list of all of our programs. So you can see we have both applied data analytics and applied data science at the bachelor's and the master's level, as well as many other programs that deal with information science. So at Syracuse, as with every other iSchool, when I speak on behalf of them, our motivation is very similar, and our mission statement is right down at the bottom there: expand human capabilities by connecting people, information, and technology. So I would encourage you to look at many different programs that we discussed today. We hope that some of you might be interested in Syracuse and we can serve you again in the future. but really we're just sincerely grateful for the time that we spent together and hope that we've offered some insight that might help you choose your educational pathway. So at this time, we're happy to take any comments, any questions that you might have either on data science or simply in how to choose a university or what it's like in the US to go to school, or open it way up to anything you might be curious about.
Thank you very much, Susan and Mike, for this amazing opportunity. It was not only a webinar, but it was like a master class on data science and all the fields involved. It was so nice. Thank you for providing this opportunity for our Brazilian students. So many valuable pieces of information, resources, questions that they can ask themselves to understand which path they're gonna follow. And well, it's priceless. Thank you very much. And so, as Susan mentioned, let's see if we have any questions here. Oh, Pedro is saying that it was very insightful. He just dropped that in the chat. Guys, do you have any questions? Please take this valuable opportunity to ask Mike and Susan about the questions you have.
But we also,
yes, go ahead, Susan.
I was just going to say, Mike and I are very involved in application review. So if any of you are a little bit anxious about how to prepare to apply for universities, we can also answer those types of questions. Yeah,
in case, because when we advise the students here, we know that some schools, they prefer that the student goes to the website, see the FAQs and so on. But as I understood from Syracuse, specifically the School of Information Studies, they can reach out to you to get more information after reading the information on the website, right?
Yeah, that's absolutely correct. Yeah, we'd love to interact one-on-one, whether it's just over email or on a video call. If anyone has any questions at the graduate or undergraduate level, we'd be happy to talk, happy to speak with them.
Great. Well, and João Pedro just mentioned in the chat that he doesn't have any questions, but we really enjoyed it as well. Oh, thank you very much, Susan, for dropping your email here. Well, it's going to be recorded, but as it's going to be available on our YouTube channel, just a question that some of the students might ask themselves is regarding how to apply specifically for the programs. Could you drop the website here where they can go straight to the School of Information Studies? And the other one is if you offer any scholarship for international students.
Yes, Sue, are you doing the link and I'll do the scholarship? Is that?
I was going to suggest the other.
Oh, okay, that works.
Since I think I work in the undergraduate and the graduate world, so I think that we might have both students in this population. So yes, at the undergraduate level, we have a general office of admissions, so they do the review and the scholarship as well. I would encourage you to reach out to admissions@syr.edu for any questions that you might have there. And at the graduate level, the admissions and the financial aid is at the independent school. So Mike and I work very closely with anybody applying or anybody seeking financial aid. So I'll take this opportunity for one more lesson, which is really important for international students. And I'm sure, David, something that you're very familiar with. But we have both public and private universities. In some countries, public or private will designate quality. That is not true in the United States. Okay, in the United States, we have exceptional and not so exceptional public or private schools. So you really need to look a lot deeper. A public school just means that some of the money is coming from the government. It's typically the state government. Okay, so the state is subsidizing some of the expense. The private school, it is not. However, universities in the United States are also heavily subsidized by their graduates. So the alumni actually make donations to the university to help make it affordable for incoming students. So many universities care a lot about diversity. Syracuse University, we absolutely do. So we have targeted awards for students from different regions of the world, because we know that if our university represents students from many different countries, then every student at Syracuse gets a better education, because they're just by nature, by living with students from different countries, learn about different cultures, and there's a higher level of respect and just intercultural skills, which are really critical to really the whole person development of the student. So we do target money specifically for international students at our university.
That's great, and I saw that, and I made a print of that screen, and of course I'll watch the recording later on, and spread it to our advisees and other students. But it's very interesting that you were also offering online programs, right?
Mhm.
And meanwhile, because Brazil is gonna take a little longer to get over the situation, maybe the online is gonna be the primary idea for many of the Brazilian students here. And so they just go to the School of Information Studies website and gonna find the ones that are online, right? And I
Yes.
assume that for the online programs, maybe the application is a little is less bureaucratic, or it's gonna be the same?
The quality should be the same, but there are some differences. The population of students in the online program are often working professionals, so they can't relocate to come to campus, where the campus students are more traditional students, kind of age-wise and such. I will say that for our online program, we have limited scholarship opportunity. So most of the scholarship is provided to the campus students, because very often the scholarship can be linked to also work opportunity. So you might come and you might work for a faculty member and get a stipend and tuition and things like that. Or you could just come, it might not be work related, it might just be a dollar amount provided just based on your merit. But so there is a little bit of a difference when you're looking at online versus campus programs with scholarship. And the other thing that you might want to consider is many international students want the opportunity to work in the United States. And it does take 2 semesters within the United States to qualify for your curriculum and practical training, which is the internship, at least if you're going to be paid for it. In our field, our students are very accustomed to being paid because they have to live. So for that reason, the campus program is much more popular than the online program for our students.
Great, thank you for answering that. Yes, because I think that for the 2022 fall and 2023 fall, we're going to be back there in the US, right? And
I certainly hope so. I'm hoping for 2021 fall that some people
actually, yes, because we have this new the new exceptions right now, and so
yeah.
and so
Yeah, you fell under the national interest exemption, right?
yes,
So
that is right.
we're hoping that means that once our embassies and consulates are able to make appointments, that students will be able to come. Keep in mind that we have a very healthy community right now. I mean, I wish we couldn't have said that a year ago. New York was in really bad shape. But 70% of our university has been vaccinated, and 50% of the greater community in Central New York has been vaccinated.
Yeah,
So things are starting to return to normal.
assigned, but it's a random thing that I'm saying, and is that Broadway is going to open for 100%
Yes,
capacity
in September.
September.
Yes, we're very happy.
Yeah, so
And-
that's amazing.
And now we can actually go to like a baseball game if we just show our vaccine card and things. So
Oh, that's nice.
yeah, so the vaccines have really started. So I pray for the whole world and for Brazil as well that
Yes,
you're just maybe a few months behind us. We started out being the worst, and we're now, the worst is behind us. And I hope the same for everybody.
Yes, and really here I think we're dealing the situation and getting to know as that, like in the US and other countries, things are going better now. This gives us hope, as I was just saying, Mike, before we started. And well, just because of the time, thinking about you and the students here, just thank you again for this opportunity. So as I said, it's going to be available on our YouTube channel. So many other students will be available to get to know this valuable information. And so thank you very much, Mike. Thank you very much, Susan, for being with us.
It was really our pleasure. Thank you to Education USA for all that you do. And thank you, students, for coming and listening and learning as well.
Yeah, thank you for the opportunity. I really appreciate it.
Thank you. Muito obrigado a vocês que estiveram aqui conosco hoje. Tem muitos outros eventos com universidades americanas, inclusive, acontecendo nos próximos dias, né? Na próxima quinta-feira, nós teremos Hood College, Graduate School, que vem falar aqui também, e tantos outros eventos, feiras como de Community College, que vai ocorrer nesse sábado, e tantas outras. Esperamos vê-los numa próxima oportunidade nesses eventos, e utilizem os recursos da rede Education USA também, que estão disponíveis no nosso site educationusa.org.br. Muito obrigado, desejando a todos e todas, então, uma boa tarde e até a próxima.